I've started recording now, so welcome to the weekly CSIG call around AI topics. It happens on Thursdays at 10:30 a.m. US Eastern typically. Today we're starting with a small advertisement for a small commercial for an upcoming digital developer conference on AI and cloud. And it's totally free, and you don't need to travel to attend it. And it's got some amazing speakers on a variety of topics. But we also have an amazing speaker today, Stephen Hammer, who's a CTO of sports in IBM, and I'm going to hand over to him to introduce himself and proceed. So you can start sharing, Steve.
Okay, let me get the sharing going. Let's see. That work?
It's beautiful, thank you.
Okay, all right, well, hi everybody. My name is Stephen Hammer, and I'm IBM's Sports CTO, and I lead the team that delivers IBM's major sporting event projects. So we deliver the digital channels for several different projects, including the US Open, Wimbledon, the Grammy Awards, the Masters golf tournament, and many others. And what I'd like to talk about today are sports summary highlights using AI. So that's taking an entire tennis match or an entire golf round and summarizing it into just a few minutes. This is something that's really important for fans. It helps them understand what happened during a match or a round of golf if they didn't have time to watch the entire thing. And it's pretty much become an expectation by fans to have access to sports summary highlights. So we introduced this at Wimbledon in 2017 and have refined the offering over the years, and it's also been productized as part of IBM's Watson Media platform. So just as a quick bit of backdrop, IBM has been involved in sports for a really long time, going back to the Olympic days, and on the screen now are some of the partnerships that we currently support. So I mentioned Wimbledon, the Masters, and the US Open. Those will be the projects that we talk about today, but there's several different other ones: Mercedes-Benz Stadium, Pebble Beach Resorts, the Toronto Raptors. So IBM has a rich history in sports, and many of these partnerships are long-standing relationships, and we use these projects as a platform to showcase technology. So getting right into it, I'd like to talk about what a sports highlight is, and specifically summary highlights. So summarizing a round of golf or an entire tennis match into just a few minutes. There's a traditional approach that editors follow for this, and I'll run through that for you real quick. So on the screen now, you see some of the elements that are commonly brought into highlights. So graphics and branding might have the player names in there. So this is the template that editors use in their editing suite, and they'll build this before the tournament starts, and then as the tournament progresses, they'll pull the content in and publish it out as their highlight video. So and this is really the anatomy of a sports highlight. As play progresses, a logger will watch that content and rank the individual scenes in the content. So this is a tennis log here, for example. It's common in tennis that the logger will mark a point with 1, 2, or 3 stars, and that helps an editor understand how noteworthy a point is. After the match is over, or the round of golf is over, editors will search the production footage and find the points that they need to build out their highlight. And on the right are the business rules that they typically follow for a tennis match. So there are mandatory storytelling elements like always show match point, always show set point, then show key moments in the match that help determine the outcome, and then include exciting and noteworthy points. And all of this is meant to be condensed into 120 seconds of tennis action. So taking a 200-point match and condensing it down to 120 seconds is a tall order. And but this is what editors are doing for typical match highlights that are published on the internet. And then the steps that an editor will follow. So they'll pull in the scenes, they'll clip based on the in and out times. They'll add storytelling elements, like you see there in the lower right, match point, or it might be voiced. And the template is updated in the editing suite with this content, as well as player names and things like that. Then the content is published out. And it may go to social, it may go to the digital channels for the event, or it may go to YouTube or other places. So that's the basic editorial process that's followed by editors. And you multiply this out times 200-300 matches, and it represents a tremendous amount of work for the editor. So in seeking to assist with this process, we stepped back and looked at everything involved and looked at the overall goals. And our partners are seeking to cover as much content as possible. And the highlights that I described before, they're highly formulaic. Those business rules are applied pretty much across the board. If you watch a highlight video for one match, it's very similar to a highlight video for another match. Each are following that template, and so it's very consistent content amongst the different matches or rounds of golf that are covered. So we sought to apply automation to this process and come up with a way to produce things automatically. We also had another goal to surface compelling individual moments for the editorial team and for fans. So if there was a super exciting moment that happened a couple of minutes ago on center court, surface that, and the editorial team can take immediate action to tweet about it, or perhaps create a custom highlight video. So the highlight packages themselves, there's two examples playing here on the right. So a tennis highlight on the top, a golf highlight on the bottom. So I mentioned the summary highlights for tennis, and for golf, the round and 3-minute highlights, that's the summary package for golf. And the round of golf is condensed to 3 minutes, and the tennis match condensed to 2 minutes. We also published out single points to IBM's live scoring application called Slam Tracker. And these are also golf highlights, single shots were also published out to IBM's track application. And then we have a dashboard, which is a back office tool for editors to use with social media and things like that. And as far as coverage goes, you can see the numbers here. At the US Open, we covered 7 courts, 31,000 video scenes analyzed, and we produced 150 highlight packages. The numbers are a bit bigger at Wimbledon. We covered 10 courts, and we covered all events. So we processed 66,000 video scenes and produced 375 highlight packages. This is our overall workflow, and we'll get into the weeds on these different points in a minute, but just as a zoomed out view, I'll walk you through the workflow. So on the left, traditional tennis stats are gathered by courtside statisticians, the referees, serve speed data, and player and ball position from a player and ball tracking system. And then on the bottom left, live video is ingested as well. So as far as the live video goes, we were capturing that live, we were detecting the individual scenes and clipping those individual scenes. We were storing the content on the cloud, and then ranking the individual points for what we call excitement. So every scene is analyzed for crowd cheering and action recognition. And action recognition is analyzing the scene for signs of player celebration. So if a player has their arms up in the air or smiling or things like that, then that's something that might denote an exciting point, and crowd noise and crowd cheering is something else. So that allows us to form a ranking of how exciting that point was, and then we scale that result with IBM OpenScale, which I'll talk about later, and then it goes through the different processing mechanisms for publishing out to the end user. So the first piece I'll talk about are scene changes. And from the scoring team, we get rough timing information about individual points. So we know roughly when a point starts and roughly when it ends, but we don't have exact timing. So to do this, we analyze that, what we call the rough cut, for individual scene changes in the video. So we extract thumbnails from the first frame of each scene. And so here we have the video playing, and the first frame is extracted from the video with every scene change. So the point just ended. The director changed the camera angle several more times. So those thumbnails there, that's the first frame for each scene change. And this interface here, this is the IBM Watson visual recognition training interface. So this allows us to train the model with using individual examples. So there's 3 different classifiers that were trained here. Tennis, and that's the overhead camera angle that's very common in tennis production. You see that in the bottom left. Replay, this is something that the director was including in the content. They would, if there was an exciting moment, they would replay a point at a different camera angle, and we would detect the graphic element that they had with that, and then also several negative examples. And you can see here that we only supplied a few examples to the system for training. So 29 tennis examples, 29 replay examples, and 36 negative examples. So this really isn't very many, and it's very cool that the system can be trained with just a small number of examples. Another cool thing is we would make changes in this interface live during the match, so or during the tennis. So if, the broadcasters would introduce another camera angle, and we could push that example into the system and retrain the classifier live while everything was in production. Here's one way that scene changes can be detected and the individual frames exported. There's a popular tool called FFmpeg. So the top left, you can execute that against a video file, and that will give you the timestamps for scene changes in the video. And then the second step, exporting the frame at that timestamp, and then the third step would be pushing it to Watson visual recognition for classification. So these are the different classifications of these images. So the first was negative, the second was detected as a replay, third is the overhead camera angle that we're looking for. Then that scene ended. And tying that all together, we can take the beginning so the tennis match that you saw earlier, and then the next frame, which was negative. So that tells us the beginning of the scene and the end of the scene. And we can then use that information to make our clipping decisions. Another thing that's an issue with this process is sometimes the camera angle doesn't change when expected. And in this case, there was a service fault, and so there's extra content there in the scene. So you see that the serve goes into the net, and the player resets and then hits the ball again. And that's where we'd want the scene to start in our highlight video. We wouldn't want to show the service fault. That doesn't make for a very good highlight. So this problem we solved with audio, and we used a tool called IBM Maximo PQI, Acoustic Insights. And a lot like visual recognition, we trained this system on individual sounds. And Acoustic Insights is mainly used in the commercial setting to monitor the sounds of machinery. So in a factory setting, if a machine is making a strange sound, that's something that you might want to alert on and bring a technician over to fix it. So we applied that same thinking to analyzing tennis sounds and trained it for these different things. So the strike of the ball, the shoe squeak on the court, applause, the chair umpire, and the ball bouncing. And the ball strikes are specifically what we're looking for to help tighten the clipping. We ran this with on the IBM cloud in a Docker container. And as part of our workflow, we extracted the audio from the video and pushed the audio to the API on the cloud. And we received a JSON response with the sound classifications and timing. This is a back office tool that we built to analyze the audio in individual scenes. So paste in the video file there, click start, and it detects the different sounds in the video clip. So you see the tags on the right, hit, that's the sound of the service fault, and you see the timing information. Then it detected an announcer, so somebody's voice, then a shoe squeak. I think that was the ball kid there. And so each of those sounds were detected, and what we were looking for was the second hit for the serve that was in, and getting that timing information allows us to then tighten the clipping. So this is the clipping after the sound classification. So we were able to remove the first service fault to create a tighter clip, and this will make for a better highlight video. And I mentioned the excitement earlier. Condensing a match is certainly a challenging thing. We have a lot of mandatory content that has to be in there for our storytelling, but getting the exciting moments in there is something that's really important. So crowd noise, and our system was trained specifically for crowd noise, not sound levels, but actual crowd noise. Player gestures, showing, analyzing the scene if the player was celebrating or not at the end of the scene. And you see there in the bottom right, Venus Williams is celebrating. We're specifically looking for. The last thing that we used was traditional tennis stats. Things like breakpoints and winners were ranked a little bit higher than other points. And we rolled all of that up into an overall excitement ranking. And I mentioned some of the numbers earlier, like at Wimbledon, 66,000 points were analyzed. So we built this overall excitement number across all 66,000 points. And that information was then used in downstream decision making on what to include in the highlight, what not to include in the highlight, and also fed into editorial decisions too. And if our client wanted to make edits to the video after the system had made its selections, they could. And decision changes were needed based on things like video rights. So they might want to make the video 180 seconds long instead of 120 seconds because they had additional rights available to them on that day. That's something that happened at Wimbledon. So we provided this editor tool so the stakeholders could go in and make changes if they wanted to. They could select different scenes, they could remove scenes, and there were a lot of different filtering mechanisms available. So you could filter by winners, by breakpoints, sort by excitement, and things like that. So this allowed them to make very quick changes to what the system had already chosen. Those are the individual elements in the workflow. So we talked about the capture of the video, the scene detection, the rankings. We didn't talk about the piece there in the middle, which is Watson OpenScale. So what we did there is we used OpenScale to help scale the results based on the circumstances of that match and that point. So early in a match, let's say it's lunchtime, the stands might not be very crowded. At 2 o'clock, late in the match, might be much more crowded. So we used OpenScale to help scale the rankings to ensure fairness between those individual points, and that then led to more accurate downstream decisions. And then on the right, those are the output generation systems. So on the top is the dashboard, which was used as the back office tool by our stakeholders, and the highlight generator on the bottom right, that was essentially a playlist builder, but fit into the production template that I mentioned before that editors would use in making highlight videos. This is our workflow from the Masters for golf. It's very similar. We clip the individual scenes. They're then ranked. We then scale them with OpenScale. The round and 3-minute highlight video is produced and then is published out. And I mentioned the dashboard. So this is the back office tool that our stakeholders used to find individual points. This was searchable. It had coverage stats in the top right. You could search by player, by stat, by round, and find individual points. And we also extended this to the broadcast team. And these timestamps, these are EVS video repository timestamps. So they can copy these timestamps into their EVS system and pull out the production video from their EVS system and then pull those into television highlights. And this is a produced highlight video. So this is live on usopen.org right now. So you saw the starting bumper, the graphic that just flew away in the bottom right that said first set. So this video was produced automatically by the system around 90 seconds after the match finished. So getting content out this quickly gives our partners first mover advantage, and it has also allowed them to greatly increase scale and really focus their video editing time on the content it needs to be much more custom and less formulaic. And there's a lot of information about what we've done out there on the internet. So if you do some Google searches for US Open or Wimbledon or Masters highlights, you'll find some of this content. So we've published a large number of blogs and put a lot of stuff out there that goes much more into depth than what I just did here. But yeah, that's the system, and guess we can open it up to questions.
Thank you so much, Stephen. That was wonderful. There has been some discussion in the chat about using these kinds of technologies for meetings, making meeting summaries and so on. I don't know if anyone wants to unmute themselves and to elaborate, or you can just read in the chat. Any comments on that, Stephen?
Well, yeah. One thing that is a pretty good use case with that, IBM did work with TED Talks and making TED Talks searchable. So the individual TED Talks were transcribed with Watson speech to text, and uh, all of a very large number of those were processed like that. And a searchable interface is put in front of it. So if you wanted to search for a topic like uh, supernovas, you can go in um, and search that interface for that keyword and see all the different matches and seek directly to that point in the individual TED Talks. But the same approach could be taken to create summaries of that content as well. So based on business rules, take the transcript of the full TED Talk or a meeting and condense it down to the most important things that you're looking for.
Great. Any other questions? And please thank Stephen in the chat if you enjoyed this session.
Hello, this is Ihon speaking. I have a question. Do you think this is possible use case to adapt to a movie to generate like a movie trailer?
Yeah, it's funny you mentioned movie trailers. The movie Morgan, the trailer was actually created with the help of artificial intelligence. So the whole movie was analyzed. The most emotional parts of the movie were identified, and those were then pulled into a video editing suite, and the trailer was pushed out. So that would be another thing that's out there on the internet. You can Google IBM Watson Morgan trailer and see some more detail about that.
Okay, thank you.
I'll also mention that in a couple of on December 12th, we'll have Aaron Bauman, who's on this call today, IBM Distinguished Engineer. He's going to speak to us about fantasy football and how AI technologies relates to that. And there's a lot of more chat going on here. Okay, so people are communicating with yes, we have the Morgan trailer. And so if there are no more questions, thank you so much, Stephen, for such a beautifully concise talk covering so much material. It was very, very good. Thank you.
Great, my pleasure.